Hello everyone and welcome back to yet another video in which I will be explaining how proof of work mining works, and then I will compare it to proof of stake minting, after which I will briefly go over the Byzantine generals problem. So let's start. When talking about proof of work mining, I will be using Bitcoin as an example since it's the most well-known blockchain that uses this type of consensus algorithm. And as you can see here, I've implemented sort of an overview, a graph, which goes over the whole process. However, it's very broad. As you can see here, it says basically that there are transactions, after which those transactions are mined by a miner and compiled into a block. Then the block is presented to every node in the system, and every node says yes, this block is correct. They validate the block, and after which the miner receives rewards, which are typically cryptocurrencies, and Bitcoin's case bitcoins. It's important to state, however, that proof of work is made to be deliberately slow and expensive. It's deliberately slow because all the nodes need to reach consensus, and also it's deliberately expensive because in that way the security in the network can be upkept in a way. In its essence, proof of work miners are incentivized to maintain the security of the network by validating transactions and then reaping their rewards for doing so. But what exactly is it? In my video about how a blockchain works, I mentioned this nonce, this random number. I just said that it's a random number that you'd have to guess or get correct in order for the block to be valid. In its essence, that's exactly what the miners do. So they calculate hashes. They have to calculate the nonce of every single block in order to get the correct hash, aka the hash that starts with 18 zeros in order to be deemed valid. So that's the whole mathematical puzzle that the miners need to solve. And since, for example, you can imagine that maybe sometimes there can be a lot of blocks and you'd need to guess a lot of nonces, therefore calculate a lot of hashes, and that's why you would need a very fast computer with a lot of computational power because it requires a lot of energy. If I can say it in other words, the main goal of proof of work is for the miners to score a specific numeric outcome that's below the difficulty target. And what's the difficulty target? Well, it's basically how hard it is to calculate the correct nonce and get the correct hash. In its essence, that's it. And the network checks every 2016 blocks if, for example, the average time of compiling a block is within 10 minutes. If it's below 10 minutes, then the network adjusts the difficulty target and makes it twice as hard to calculate. And if it's more than 10 minutes, then the network does the opposite. The difficulty target decreases, so it's easier to calculate the hashes. Then what's the difference between proof of work and proof of stake? So as I mentioned, in proof of work you would need a lot of computational power, but in proof of stake you don't need that. You don't need that because there are no mathematical puzzles to be solved. There are no nonces or anything like that. So the only thing you would need if you want to start minting is for you to have a certain amount of cryptocurrency in your wallet. So in Ethereum's example, you would need, for example, let's say, just a pure example, 100 Ether, so you can stake it and use it as collateral in order for you to be able to participate in the minting race, even though validators are selected based on a lottery principle, so it's sort of completely random. But if, for example, let's say 5 minters, they staked 100 ether and you staked 150, then of course naturally your chance to be the next validator will be way higher. So let's say you got chosen as a validator. After that, you get all the transactions, put them in a block, then you'll present the block in front of the other nodes. They'll say, yes, everything's fine, they'll confirm it, validate it, after which it's going to be added to the blockchain. And also, very important, in proof of stake, you don't earn cryptocurrencies like in proof of work. You earn the transaction fees from the transactions that you minted. And here I also have a pretty handy graph which sort of highlights the most important differences between proof of work and proof of stake. I mentioned that mining requires a lot of computational power, whereas proof of stake, you just need to stake cryptocurrencies or your reputation or whatever. You just stake something. In proof of work, you solve a cryptographic puzzles, and in proof of stake there is no puzzle and you collect the transaction fees as a reward. The only thing I did not mention is that in proof of work, if you want to perform a 51% attack, you would need to hold 51% of the computational power in the system, whereas in proof of stake, in order to do such an attack, you would need to hold 51% of all the cryptocurrencies on the network. And needless to say, in both cases, it's almost impossible to perform such an attack. And even so, let's hypothetically say that in proof of work you succeeded to perform a 51% attack, and let's say you have a hold of the Bitcoin network and you can get a lot of Bitcoins, you can double spend them, but is it really worth it? Because if you have such a control and you are able to double spend your coins and whatnot, then the whole value of the whole Bitcoin network will just depreciate. So in the end, there's really no point. It's way easier and it's more worth it for you to just keep mining and keep earning rewards. And then last but not least, we will go over the Byzantine generals problem. In short words, the Byzantine generals problem just depicts a situation in which there are, let's say, 3 generals right here, blue, red, and yellow, and they want to conquer a city and they want to attack it at the same time. So the whole problem is, how are all of them going to be sure that all of them are going to attack simultaneously at the same time? You would say, well, maybe the red general can send a messenger to the yellow one and send him a message saying, hey, let's attack at 10 a.m. or something like that. But what could happen is that the messenger could get killed midway, right here, for example, and get replaced with an imposter, which will go to the yellow general and just give him malicious information. Or even if the messenger did make it, how is the yellow general going to be 100% sure that this is not an imposter? This is the whole dilemma of the problem. And how it relates to proof of work? Well, in blockchain terms, this problem depicts the whole dilemma of all the nodes reaching consensus on the single source of truth. And Satoshi actually managed to kind of bypass this problem. He did not solve it, but he sort of bypassed the whole problem by creating the longest chain principle. So the longest chain principle in proof of work is basically this. Let's imagine that there are 2 blocks that have 2 different truths. So block A states, no, this is the truth, and block B states, no, this is the truth. And now the nodes have to decide which 2 of them is it. And Satoshi made it fairly simple. He just said, follow the longest chain. And let's say if this chain is longer than this chain, then of course this is going to be determined the single source of truth, and therefore consensus has been reached. So yeah, that is basically the core elements of mining, minting, and the Byzantine generals problem. I hope you understood everything. I hope I did not leave anything out, and I hope you enjoyed it. Thank you very much for watching.